In section 1.3, we're going to be looking at rates of change and behaviors of graphs. So as we kind of lean into this, let's just go ahead and kind of get us some notes and formulas to get us going, but this will look familiar to you. The first thing I want to look at is average rate of change. When I'm looking at average rate of change, we're looking at the formula or idea of slope. And when you remember slope from previous courses, previous math, let's just kind of line that out and look at all the different ways that we even considered slope. But again, slope or average rate of change is just another way of saying slope, is the change in y over the change in x. Sometimes you see it as delta y over delta x, and that triangle just means change. y2 minus y1 over x2 minus x1. You're having flashbacks to algebra. Or what we're typically going to see when we do average rate of change is your function notation. F of x2 minus f of x1 all over x2 minus x1. And so look at this problem that we have next. Example 1, given the function shown here, find the average rate of change on the interval from 0 to 3. Now let me just emphasize that this right here is an interval. A lot of students, it throws them because you're so used to working with the elementary examples of ordered pairs that 0, 3, you do not recognize that these are actually your values of your domain because it's an interval. So when you're looking at this 0, 3, this is your x1 and this is your x2. This means going from 0 right here to 3 right here. They're wanting to know the average rate of change or slope, say we were to connect them. So I'm going to know, how did I get from 0 to 3? What was that average rate of change? So now you have to look at your function. You have to say, okay, well, let me pull some more information here. So first of all, if I look at f of 0, or this is your f of x1, well, at 0, it's at this point here of 1. So that's the ordered pair 0, 1. You can see my ordered pair is parentheses, whereas that interval had brackets. And so if I want f of x2 or f of 3, I'm just going to go over here to my graph and look at 3, and that's at 4. So I'm going to say 4. So if you like, my ordered pair would be 3, 4. Now using that information, I could do slope. M is equal to f of x1, 2 minus f of x1 all over x2 minus x1. I'm just going to plug in the information that I have. So that would be 4 minus 1 over 3 minus 0, which gives me 3 over 3, which is just 1. Which makes sense because that red line I drew is a positive slope of a linear function, and so you can see it's going up at an average rate of change of 1. Let's look at another one. This one had a graph, and so I wanted to show you how to kind of pull that information out of a graph. Let's look at example 2. It says compute the average rate of change on the interval from 2 to 4 of, and here's our function, f of x equal to x squared minus 1 over x. And problems like this is what gets students, because you're so used to being kind of spoon-fed the information. But we're to the point like you need to be able to pull the data out that it's telling you. So this is your x1 value and this is your x2 value. So we're going to approach it just like we did in the last problem. You're going to have to use your calculator on this. So grab your scientific calculator. And if we're looking for f of 2, that just means instead of x, we're going to put a 2. So I'm going to plug in 2 right here wherever I had x's. And so I would say 2 squared minus 1 over 2. That gives me 4 minus a half. I love a good fraction, exact number. So if you plug that in your calculator, change it back to a fraction, this gives you 7 over 2. All of your answers needs to be in lowest reduced fraction form. I'm not super fan of decimals because a lot of times you can round those and you're not working with exact answers. So your ordered pair would be 2, 7/2. Now if I want to find f of 4, I'm going to do the same thing. I'm going to plug 4 into my given function, which gives me 16 minus 1/4. Grab your calculator and you're going to type that in. 16 minus parentheses 1 divided by 4, just using your scientific calculator. And that gives you a value of 63/4. Again, I want lowest reduced fractions in proper fractions, not your decimals. So this gives you 4, 63/4. So now if I find the average rate of change, I'm just thinking slope. So I'm going to say m is equal to f of x2 minus f of x1 all over x2 minus x1. So this gives me, let's see, 63/4 minus 7/2 all over 4 minus 2. So if I get common denominators, that'd be 63/4 minus 14/4 all over 2. So that's 49/4 divided by 2. Just use your calculator with that. And remember, when you divide fractions, you keep it, change it, flip it. So you're doing 49/4 times 1/2. So it gives me 49/8. And again, you can use your scientific calculator with that. No graphing calculators, but you definitely need it to be able to evaluate your scientific calculator, that is. And so you get a final answer of 49/4. I like lowest reduced fractions as you work with this. Now don't let the fractions freak you out. The process is what we're learning. Any of the values, fractions, etc., dividing fractions, that's old. Like, that is old content. That's middle school working with fractions. So you can have values such as that. Not everything's are nice 2s and 4s as you work in this course. And so average rate of change, just remember that slope, and remember that when you're working with this, this is an interval and it's your 2x values. Now the next thing I want to talk about is behaviors of functions. I'm just going to kind of scroll this up here. When we're talking about behaviors of functions, we want to look at kind of what is going on graphs, or based off what we could see on their equations. And so the first thing I want to kind of do is I want to kind of define some things and work from there. When we're looking at increasing and decreasing functions, a little bit of vocabulary and writing here, jumped up there. We are looking at an increasing function. An increasing function is when the average rate of change, or slope, is positive. And when we're looking at a decreasing function, we're looking at when the slope, or the average rate of change, is negative. And so when your slope is negative, that's where your function is decreasing. We look at the increasing and decreasings of a function because we want to look at something called local extrema. Defined as that, a local maximum is when the function changes from increasing to decreasing. And this is in pre-cal, and so we're just kind of touching base on this. But as you move into calculus, which is why a lot of students take pre-cal, when you move into calculus, we kind of identify this and do some calculus concepts more on how to find these. But just as a basis, your local maximum is when the function changes from increasing to decreasing. So if I'm increasing and then decreasing, this point right here, so increasing, decreasing, that would be where your local maximum is. Local minimum is when your function changes from decreasing to increasing. And I know that you could look on a graph, so decreasing, increasing, there's your minimum. I know you could look on a graph and see where this is, but we need to kind of look at it some more and make sure we understand what's going on with functions so we can take it off of a graph and just look at some more information. So we've got our minimums, we've got maximums, we've got increasing, we've got decreasing.